Hello, everybody, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 2, Lesson 6. We are continuing our study of inequalities and specifically compound inequalities. Last lesson, we discussed it when it is an or compound inequality, but now we're going to look at it when it's and. Alrighty, so what is that? Today's objective is I can solve compound and equalities. And you can graph those and equalities. Alrighty, so let's go ahead and take a little bit of notes about what this is. Okay, an and compound inequality, the solution is only the area that is the overlap of the two inequalities. Example, you could write it as this. We have a compound inequality of 4 is less than or equal to x plus 4, which is less than or equal to 8. So your problem could be given as this, and then we're going to break it up into two problems to think about it in two different ways. So if we take just this left half, we could think of this as a simple inequality, and this is easier to kind of mentally deal with. So we've got 4, whoops, it would help if I was actually writing 4 less than or equal to x plus 4. And then we can take the other and we can split this part off. And so we have x plus 4 is less than or equal to 8. And so we're going to break this equation into this original equation that I wrote. We're going to break it into two equations, or I should say two inequalities. And then you'll solve each inequality and graph Hello, everybody, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 2, Lesson 6. We're going to continue our studies of inequalities, specifically in this case, compound inequalities. Now, remember, last lesson we talked about or inequalities where the solution had to be in the range of one of the inequalities or the other one. Today's different because it's and inequalities. So what does that mean? Well, let's get into it. So our objectives today is I can solve compound and inequalities, and I can graph these compound inequalities. And the difference between or and is the solution for an and compound inequality is what makes both inequalities true. Okay, so let's write down some stuff about that. All right, and in compound inequality, the solution is only the area that is the overlap of the two inequalities. So you could be given a problem that looks similar to this, where it is 4 is less than or equal to x plus 4, and then less than or equal to 8. And another way that you could write this is we would break this up into two chunks. So I am going to look at this left portion, and I'm going to think about this as just this kind of simple inequality that I see right here in that circled area. So I can break it up like this, where I have x is less than or equal to x plus 4. And I can use the other part. I can write a simple inequality here about this part that's circled, where it's x plus 4 is less than or equal to 8. So you could see it in one of these two formats. Okay. The two formats being it's written together like this, or it's written together like this. Alrighty, so the steps that I just did are step 1, break the inequality into 2 inequalities. And then step 2, you're going to solve each inequality and graph the area that they overlap. So what does this look like? So it gives us this compound inequality here, and it looks really crazy because, you've got 2 inequality symbols in it, and it says to graph the solution. Well, how are we going to do that? I'm going to come up here to my step 1, and I'm going to break that inequality into 2 chunks that look a little easier to my brain. Okay, so I am going to, like we got 1 inequality symbol here. So I'm going to take the thing that's to the left of that and the thing that's to the right of that 1 inequality symbol. That is my first chunk, this thing that I've circled here. So 1 is less than 3x plus 1. And then my other chunk is going to be, I look and see I've got this inequality symbol here. It's going to be the thing that's to the right of it, and then the thing that's to the left of it, but not including this symbol, right? So we're just taking this and this. So let's write that down, and I can write it over here. I've got 3x plus 1 is less than or equal to 13. Okay, so I've broken it into 2 chunks, and that just kind of makes it into easier bite-sized pieces for us to think about. So we have accomplished our step 1. Our step 2 is we're going to solve each of these. So let's do that. So starting over here with this pink one, I am just going to do the same thing that I have done with all of them in this unit so far. We're going to subtract 1. We're just going to start rearranging everything till we get x by itself. So that cancels. I'm going to bring down 3x, the less than or equals, and then 13 minus 1 is 12. Okay, so when 3 is touching x, that means multiply. So to undo that, we're going to divide by 3, and we're going to divide by 3, and that cancels. And you get x is less than or equal to 4. That is the first half, or I guess in this case, because it's the second half, that's one of the halves of my compound inequality. It is not the whole answer, but I can go ahead and put this right here. Okay, so what does this mean? I can even write it here, bringing it together, above where I've written it. Let's go do this one here. So I'm going to subtract 1 from both sides. Don't let it throw you that 1 minus 1 is 0. Okay, we're not going to get sad about that. If we divide by 3 on both sides, 0 divided by 3 is still 0. Okay, my x we can have 0 on here. That's okay. Okay, so I've got my 0. Now, what am I going to do about this? What does this even tell me? I've got this chunk here that I need to bring over and do something with. And I have this chunk here that I already brought over. How do we put that together? Well, if you look and see, you'll see that this x is right here on the right side and my x is over here on the left side. We can bring these two together. So we can write it like this. We can go 0 is less than x. And I only have to write 1x because, and then less than or equal to 4. So what this answer here is telling me, my answer has to fall in between 0, okay, and it can be anything in here. And then because I've got that equal bar in there, I know I've got a shade in this circle, it can equal 4. Out of all the numbers in the whole universe, This pink shaded area is all the answer that you see. The 0, we had an open circle there because it didn't have an equal sign. So the answer to this inequality cannot be 0 itself, but it can be 0.000001. It could be a very small number, all the way up to 4 and including 4. Okay, so we're going to practice just writing a compound identity for the graph. So if we have this here, what on earth is this telling me? Okay, so the first thing that I'm going to do is I'm going to think about this area in the middle, and I'm just going to go ahead and write X there. Okay, and then the next thing I'm going to do is I'm going to look at what is this number over here on the left. And I can see it's -6. And then I'm going to look over here and I'm going to say, okay, what's this number over here on the right? And I can see it's 2. And then all we have to do is decide what kind of inequality works with a open circle. And so for the X to, for it to be shaded here, it's going to be this symbol. And we're not going to have the equal bar because that's not filled in. This one is filled in, and so we can put that. So what this identity here is saying is that your answer can be, any number greater than -6, but no more than 2. So it's going to be either less than 2 or equal to 2, and then it's going to be greater than -6. So it can be negative 5.9999999 all the way up to and including 2. So any number between 5.99999 going to infinity, all the way up to 2. The box that I made, that is the answer that this question is asking. I'm trying to just explicitly state what this is meaning by writing it in the words here and then this kind of number range. Okay, this one is going to ask us to write a compound identity for this guy here. And we're going to do the same process that we did over here, where we're just going to put our X right here in the middle. Okay, because it's shaded in the middle. So I'm just putting my X right there in the middle. I am going to write down the number that this guy is and the number that this guy is. Both of these are filled in circles, so I know we've got an equal component in it, right? Well, my X is going to be either greater than 0 or equal to 0, or less than or equal to 4. So my number can fall anywhere between 0 and 4 and any number in between that. That is what this statement says. Now, just as a way of a review as to recalling what we did last lesson, we could write a compound identity for this guy. So, notice this is shaded in the middle. These are shaded apart, right? So it's a different kind of statement entirely. I am going to put, it's shading this way over here. So I'm going to put my X on this side. I'm going to write my number. And so my 0, this here, it's a filled in circle. So I know it's going to have that equal sign. And my answer can be equal to 0, or it can be anything less than 0. So we get that. Now, because I have two shaded regions, I know this is going to be an or rather than an and. And so I can write it over here. My X is over here. My 5, I can write my 5 right here like this. And so my X can be anything greater than 5, because everything shaded this way is a possible answer, but it's not 5 itself because that's an open circle. We can pancake flip this if we wanted to, and we could write it x is, x is greater than 5. This is 2 ways to write this, but just kind of going off of a graph, the way that I wrote it originally is a little easier for our brain to visualize. Okay. Okay, so back to the original problem like we did up here, where it said to graph the solution and we were given this crazy guy. We're going to break it up into 2 chunks, and then we graph the area that it overlaps. So what does that look like? We see this crazy looking guy right here. We are going to immediately take it and break it into 2 chunks. So over here, I'm going to write everything that is over here on the left-hand side up to this inequality symbol. So I'm going to write 5 is less than or equal to 4x plus 1. Now, the other one that I'm going to write is going to be everything over here. It's this chunk. We're not going to include the inequality symbol here between that 5 and the 4x. We're not going to include that because we've already got 1 right here to deal with. So we're going to do 4x plus 1 is less than or equal to 3. So now that we've broken it up into 2 halves where we can just kind of think about it a little bit easier, we can solve it. So we're going to subtract 1. We get 4x is less than or equal to 12. And we can divide by 4. And we get x is less than or equal to 3. So we know we're going to have something here with 3. This, it's got the equal bar in it, so we know that we're going to shade this in. Let's solve this one. I can subtract my 1 from each side. 5 minus 1 is 4. And so I've got that's less than or equal to 4x. Divide by 4. Divide by 4. 4 divided by 4 is 1. So this is telling me my x can be equal to 1. And so we're going to fill that in because it's got the equal bar. And then it can be greater than that. But it can only, when we combine these two together, it can only go up to 3. So if I took both these halves and I smashed them back together again, we could get this. I'm going to write. You don't have to write it quite this explicit as what I'm doing right here. I'm just showing you what I'm doing to put it back together into one big answer. But see this x here and this x here. I'm just going to write 1 is less than or equal to x less than or equal to 3. Okay. So essentially I took this 1 and I wrote it right here. I took this 3 and I wrote it right here. My circles are shaded, so I made sure that there's an equal bar in this, and then I put the x in the middle because my x can be anything between these guys, including those 2 points. So the graph is my answer, and then this box here is my answer. I hope that helps, guys. Until next time, bye.